Hey guys, today we're going to be talking about vectors. So I'll be introducing the topic vectors to you. One of the first things you learned in physics was that we have two types of physical quantities. We have those quantities that have magnitude only, which was defined, which we describe as scalar quantities. And we have quantities that have both magnitude and direction, which we define as vector quantities. And of course, when we talk about magnitude, we mean size. Okay. Now, so we can define a vector quantity as those quantities that have both magnitude and direction. Now, in mathematics, we can represent a vector quantity as a directed line segment. This is what I mean. Now, what I have here is a vector. I call this vector AB. Now, this line segment shows me the magnitude and the direction of the vector. This is the magnitude, the size of this line. Okay, this is the magnitude, the size of the directed line segment. Then this is the direction. Where this arrow is pointing is the direction. Now, the arrow pointing from A to B means that if I want to write this my vector, I will write it as AB with an arrow in this direction, meaning that the vector moves from position A to B. All right. Um, Now, so if I have another vector, say I have another vector CD or DC, let me write it this way. Now, what do you think this vector is? Is it CD or DC? Now, the answer will be DC because the vector moves from position D to position C. All right. Now, next, if you read the note, I described what a negative vector is, and I said that the negative vector of another vector, let's say vector A, let's draw a vector A. Mind you, we can also represent vectors like this with lowercase letter, but if we want to do so, we'll put a bar underneath this. Now, if this is a vector A represented in both magnitude and direction by this line segment, the negative vector of this is another vector with the same magnitude but in the opposite direction. If I can draw another line segment with the same magnitude as this but moving in the opposite direction, let's assume that these two lines are of the same size. We'll call this line segment. This line segment is called the negative vector of A, all right, or negative A. Now you can see that they both have the same magnitude, but they are moving in the opposite directions. Okay, so this is what we define as a negative vector. Okay, now let's look at another one. If I have vector CD, okay, now what do you think the negative vector of this CD will be? It will be, now this first one is vector CD, while this is vector, this is, since this is moving in the opposite direction and is of the same size as this first one, we can call this minus vector CD. Okay, so this is the negative vector of this. Okay, this right here is the negative vector of this one. All right, but you can also see that since we say we described a vector, we can write a vector following the direction. So we can see that negative CD can also be represented by DC. Okay, So let me clear the screen a little bit. So this means that I can write my negative CD as what? DC. Alright? So what does this mean? It means that if I have a vector moving from if I have a vector moving from point P to point Q, the negative of this vector will be a vector equal but opposite to this from P to Q. So this will be minus vector PQ, which is the same thing as which is also the same thing as vector QP. Sorry that this is rough. Okay. Now the next thing we're going to see is how can we add two or more vectors. Okay. How can we add vectors? So we're talking about addition of vectors. Now we can add vectors by using what we call the triangular rule of addition. Okay. Now the triangular rule of addition, law of addition states that if two vectors are represented by two sides of a triangle in both magnitude and direction, then the third side of the triangle represents the magnitude and direction of the vector of the resultant of those two vectors. Okay, so let's say we have vector AB. We want to add AB plus BC. We want to add vector AB plus BC. Now what do? We represent vector AB and BC in both magnitude and direction by the sides of a triangle. So we can have this. Let's say this is A and this is B. Then this is my BC. Okay. Now you can see that I've represented these two vectors in both magnitude and direction by the what sides of a triangle. Okay, so let's assume this is the direction of vector AB and this is the direction of vector BC. So we represented it in both sides and magnitude by the adjacent by the sides of a triangle. Now the resultant, according to the triangular law of vectors, the resultant of these two vectors AB and BC will be the third side of this triangle. Okay, so it means that the direction and the magnitude of this vector will be given as this. Okay, sorry, this is a bit rough. So this line here represents the sum of these two vectors. Now how do we know where to put the arrow? I'll show you a simple trick. So we have here that AB plus BC is equals to AC. Now, there's a simple way of knowing this, of doing this. You have that this is going from point A to point B. This vector is moving from point B to point C. Okay. Now the resultant of this vector, the magnitude will be given by the length of AC, and the direction will be given by the arrow of this third line. Okay. So this is it. We are moving from A to B and from B to C. So the direction of the resultant will be what? From A to C. So that's how we have the direction pointed from here to here. Okay, so that is how we add what? Two vectors. Now let's try another one. And so we have So we have vector PQ plus QR. Okay. Now if I write PQ as this and QR as this, the resultant of PQ and QR will be the third side of this triangle. So to be given by this. Now the direction, where do you think the direction will be from? Yes, you got it. This will be the direction. So here we have that PQ plus QR will be equals to PR. Now in the next video I'll tell you more. Alright, but have a nice day.